A number of language enhancements to the JDK7 were done under codename Project Coin. Project Coin was tasked with determining a set of small language enhancements which would lift restrictions and make development easier. An open call for proposal period ran from January 27th to March 30th in 2009 and resulted in nearly 70 submitted proposal forms, and of that only 5 made the cut, and some were deferred. Here are the features that were implemented in JDK7. Java SE7 added the string data type for the target to switch statements. This lets us use the clean switch statement to compare strings, instead of a chain of if-then-else statements. The new try with resource statement lets us declare our closable resources as part of the statement. Then the try will close the resource for us when it exits, without us needing a finally block. And the try statement has 2 other enhancements as well, multi-catch and a more precise rethrow. We can now catch multiple exceptions in each catch block, significantly cleaning up our code. And we can rethrow more explicit exceptions from the try statement as well. The generic diamond operator has been added, which provides improved type inference during genetic instance creation. And in the data type area, we now can use binary integral literals and underscores in our numeric literals for improved readability. Lastly, there have been improvements to how the compiler handles parameterized types that are non-reifiable at runtime, which simplifies handling of var-arg methods that use these parameterized types. The switch statement takes an expression, which it compares against each case to find a match. The Java SE switch statement restricted the data type of this expression to these types. When primitive types, we had byte, char, short, and int. We had primitive classes that wrap these primitive types of byte, character, short, and integer, and we could use enumerated types. The Java SE7 release expanded the legal data types to include the string object. When given a string object in its expression, the switch statement makes the comparison with each case label, as if using the string equals method. Now, string equals is case sensitive, and so is the switch compare. So we'll have to take precautions to ensure the target and the cases are the same case. Our switch statement class is going to be emulating stoplight. So it has properties for all the stoplight colors here, green, yellow, and red. Now notice they are all in lowercase. Our main is going to create 2 stoplights, light old and light new. And we're going to give each one of them a different color. Then with the old stoplight, we're going to do print action old and print action new on the second stoplight, pausing between them so we can look at the code. So let's look at the print action old method. The print action old method uses the old way of performing string compares. First, we make sure the color is not null that we were given, and then we use this chain of if-then-else statements to determine the color using the equal ignores case, and then we take the appropriate action. Now you can see, even with this very simple task of finding the action for a streetlight color, this code is cumbersome and hard to read, but it does run correctly. It was given red, and it correctly determined that we had red, so it told us to stop. Now looking at the print action new method, we again make sure that the color is not null. But then we use the color as the target of our switch statement. And once we determine the color, we do the action. And this runs equally well. It was given the color green, and so it tells us go. But the string comparison with the switch is much cleaner and easier to read, which means it will be easier to debug and maintain. Now note, the switch compare will throw a null pointer exception if the target is null. So we'll want to check that the string expression is not null first. Also, the switch compare for strings is case sensitive. So notice we converted our target color to lowercase before we did the comparison to match our property values, which we were using that were also in lowercase. You can see up here. Now both these methods work equally well, but looking at the old way of doing it with the chained if-then-else and our new way with the switch statement, you can see which one you'd really rather look at if you were looking at code. And also the switch will be more efficient because the Java compiler will generate more efficient bytecode for a switch statement than the chaining if-then-else statements doing our string equals. There are several nice enhancements to the try-catch statement. The new try with resource statement gives us automatic resource management. Resources include objects that implement the Java lang auto-closable, and they must be closed after the program is finished with them. With the try with resource statement, we can declare one or more of these closable resources to use within the try block. Then the statement will ensure that each of these resources is automatically closed once we leave the try-catch block. We no longer need a finally block to ensure our resources are closed. In JDK 6, we needed a separate catch block for each exception being handled. With JDK 7, we can now combine multiple exceptions in one catch block, which leads to less code than when multiple catch blocks were used, each containing the same exact error handling code. And the JDK 7 compiler has been updated to perform more precise analysis of rethrown exceptions. This enhanced type checking enables us to use more specific exception types in our method declaration throws clause. And we can also now read suppressed exceptions from the exceptions we do catch. This is helpful when an exception occurs in the try block and another occurs in the finally or catch block while cleaning up. So let's see how these look in code. In our try-catch statement class, we'll start by showing how automatic resource management works. We have two stream properties here, file IO, file OS, and data OS. And we're going to use test with resources here to test two ways of managing these streams in a try-catch statement. We'll first call manage with finally. And this will be doing the old way of managing resources. And then we'll call try with resources, which uses our new try with resources statement. Now notice we're catching exceptions around either one of these calls, so we can print out the exception that we catch. Coming down here to our manage with finally method. Our manage with finally method demonstrates how we used to manage closing these resources in a try block. We're using our two file stream classes here, and both need to be closed when we're done with them. So we have a finally block. And the finally block executes if the try block exits successfully or by throwing an exception. It closes our resources for us. The issue is, what if both the try block and the close throw exceptions? To simulate this, I made our try block throw an exception. We're going to close our file OS, and then we're going to try to write through it. So we should get an exception that we will hit here, print out something, and then we'll go to the finally and close. And I'm simulating an exception being handled from the close by throwing my own here, giving it a thrown from finally block. So we'll be able to see which exception we get. And we'll know because our test try with resources is going to catch that exception and print it out. Let's see what happens when we run. We'll put this down at the bottom. We see that we caught our exception stream closed, as we expected to. And then the finally block threw its exception, and we see that happened. But when we got to test try with resources and caught that, The exception we caught was the one that was thrown from the finally block. The real exception from our try block was suppressed. In fact, we don't even know from the calling code that there was an exception thrown from this try block. So this was fixed in Java 7, and was going to show here in the try with resources. Java SE7 can automatically close resources for us using the try with resource statement. Notice how the try statement has a parameter list. And this is where we're declaring our streams. Now, you can have multiple resources in this parameter list, and you separate them with a semicolon. These resources will be closed when the try statement exits, whether the try completes normally or throws an exception. Now, there's some considerations to keep in mind. The resources must be declared within the try block parameter list. And multiple resources are closed in the opposite order of creation. So here, Data OS will be closed before File OS. Now, what about our issue? We're generating the same exception in our try block. We're closing our stream and then trying to write to it. Now, what if the try with resources close that's done under the covers also throws an exception? Well, I can't make that close fail, but let's run this anyway. Okay, we closed our stream, we caught the exception, and we rethrew it. And up in our try with resources, we caught the stream closed. Now, in cases like this, where an exception is just rethrown, there's no need to even have this catch block anymore, since our try with resources will do all our cleanup for us. And in the try with resources statement, even if the implicit close threw an exception, the real exception from a try block would be the one that was thrown from the method. The one of the close would be suppressed, but it wouldn't be lost. Going back up to our calling statement here, we can see we got our exception and printed it out. Then we asked, are there any suppressed exceptions? And we can get the suppressed exceptions from the caught exception using the getSuppressed method. Now, up to 2 exceptions can be suppressed that we can get with this method. Note, you can still use the catch and finally blocks in the try with resource statement. If an exception occurs, the try statement declared resources will be closed first automatically. Then the catch and finally blocks will execute. Multiple exceptions in a single catch block. We have this method for exception method, and it has the possibility of throwing 4 different exceptions. Though the file not found exception is derived from IO exception, an activation exception is derived from unknown object exception. The old multi-catch method here shows how we caught exceptions in Java SE6. We were only allowed 1 exception be caught per catch block. This was an issue because we needed multiple catch blocks, even if we were doing the same thing in each one. You can see here, file not found exception and unknown object exception just print out the exception, while IO exception and activation exception print out the exception and then rethrow it. This caused a lot of code bloat and clutter, which is hard to understand and maintain. Also, the order of catching exceptions is significant, since some exceptions are derived from more general exceptions. And it all led to the temptation to do this, catching a single broad exception as we've done here, which does not allow the method or the calling code to take different actions depending on the exception that's being caught. Our new multi-catch method uses the Java SE7 feature of catching multiple exceptions in a single catch block. We separate the exceptions with this bar character. Now it's easy to see we only have 2 actions, and the exceptions that create each of these actions. This code is also more efficient, as the bytecode for multiple exceptions is smaller than the mini catch blocks. Now note, when we have multiple exceptions in a catch block, the exception we catch is final. We cannot reassign the exception to a new type. The catch parameter is implicitly final if more than one exception is used. Here, if we try to delete this comment, so we try to reassign this exception here, we see we get a compiler error. The parameter x of a multi-catch block cannot be assigned. The last try-catch feature deals with rethrown exceptions. And the rethrown exception method here demonstrates the restrictions on rethrown exceptions we dealt with in Java SE6. Our try block throws two specific exceptions, file not found and file system exception. But we're catching a much broader exception, IO exception, and we're throwing it from our method. Java SE6 would not allow us to throw our more specific exceptions. That's because it did not allow us to put them in the throws clause. Here we have to throw the IO exception from our method, even though the try block throws these more specific exceptions. The issue was that broad exception catching forced broad exception rethrowing, which does not allow the calling code to take different actions depending on the specific exception that happened. Now if we look at the rethrows general exception down here, this shows the improvements to the rethrown exceptions in Java SE7. We now are allowed to put our more specific exceptions in our throws block. And we no longer have to specify the general IO exception we caught. So the calling code can set up different catch blocks. So the calling code that calls this method can set up different catch blocks to take different actions on the specific type of exception that we're throwing. In Java SE7, if you declare an exception type in the throws clause, the compiler is going to verify that the exception is one that the try block can throw. It's not caught by any preceding catch blocks that can handle it, and it's a subtype or supertype of the catch clause's exception type. Here the compiler figures out thrown exceptions from the try-catch block are either file not found exception or file system exception, so they can be included in our throws clause. Now this works unless the catch exception parameter is reassigned. If I uncomment this line, we see we get an exception. We now need to specify IO exception in our throws block because the compiler knows the two specific exceptions are not thrown from the method.